Hello, welcome to STR8CHEM. In this video, we're going to learn how to solve some problem with regards to second order reaction. Let's start with this question right over here. The decomposition of NaOCl gas to NO gas is a second order reaction. So this one is slightly easier because the question tells you what the order of reaction is. Then we know that the integrated rates equation that we need to use is going to be 1 over concentration at a given time minus 1 over concentration initial. Okay? So equals to KT. So you have equals to KT right over here. And step 2, what we need to do, we need to think about what the question wants. The question wants to find the concentration at a given time after 40 minutes. Okay, 40 minutes, it's right here. Okay, so the question wants you to find the concentration after 40 minutes. So the question gives you these two information. The first one, the initial concentration is 0.05. So that is the initial concentration. And the K value is liter per mole per second. From these piece of information, when you put that into your equation, first of all, what you need to do, you have to write let A equals to NaOCl. That is important for you to describe or explain what is A. Otherwise, your scheme of work will be deemed invalid. And time, you have to change it to second, 2400 second. You cannot use 40 minutes right away. The reason is because it must be changed based on the K units. The K units right now is liter per mole, and you have, if you look here, seconds. Okay, so you have that indicator over there. Because of that, we need to have time in terms of second. So you'll get this part over here. Okay, this whole thing over here, you will have 1 mark. And for that, usually, since the question tells you what the order of reaction is, so, and then you have write let A and OCl over there, you will get 1 mark for your formula. So the step number 4, what will happen now? We're going to use the integrated rates equation. We're just going to substitute the value over here. We have initial concentration, you have the value of K, and you have the time. So you're just going to plug in all the values inside, and you'll get something like this. Okay, so that is the initial concentration. Initial concentration. Okay, so the initial concentration is that K value. That is the K value. And time, the time is right there. And we want to find out what is that concentration at a given time. So you solve the problems, and thus you would be able to get the concentration at a given time, 8.62 times 10 to the power of -3 molar. By doing this, you will get another 1 mark for your final answer. Okay, so the next one, we have the gas phase decomposition of nitrogen dioxide to NO2 gas to produce 2NO gas plus oxygen gas if the rate constant K at a certain temperature is 0.033 mole per mole decimeter cubic per minute and the initial concentration is given. What is the time when the concentration of NO2 has reached 0.08 mole per decimeter cubic? Step 1, again, we have to identify what is the order of reaction. The order of reaction is second order reaction. The question doesn't say, but we can identify that from the units given. Okay, from the units right over here. So that is the hint for second order. Since the K units is per molar decimeter cubic per minute, also same as per molar per second. So I'm just going to change that. So this is okay, so it should be per molar per minute. Okay, but my point is, when you get that units right there, that is the indicator this whole thing will proceed via second order reaction, and we need to use this integrated rates equation to solve this. Now, step 2, you need to find out what the question wants. Okay, the question wants you to find time when the concentration at a given time is 0.08 mole per decimeter cubic. Okay, so that is what you are given, and the question wants you to find the time. And the question gives initial concentration and also the rate constant. Okay, you have initial concentration. So that is the initial concentration, which is this initial concentration, and the value of K right there, which is 0.033. Step 3, the final one, substitutes all the value inside, but first, always remember to let A equals to NO2. You need to define what is A. So that one will give you 1 mark, like so. And then you substitute all the value inside. You'll get something like this. And finally, you should be able to find the time. So this whole thing over here will give you 1 mark, that 1 mark. Okay, this one is just a statement, so it doesn't have any mark. And this one over here, you will have 1 mark.